Good morning. Today we are going to talk about verifying a tangent and finding the radius of a circle. So there's two different theorems, a tangent line to a circle theorem and the external tangent congruence theorem. So if you look at that diagram there, if we have a line that is tangent to a circle, which means it's touching the circle at one point. So in this diagram here, we're talking about this point P. So it's touching at point P, but it is tangent if and only if, so that's a biconditional statement, if and only if that line is perpendicular to the radius of the circle at its endpoint. So what's important there is that it's perpendicular, and perpendicular meaning it intersects at a 90-degree angle. So if it intersects at a 90-degree angle, then you know it's perpendicular, which then you know that that line is a tangent. The other one is if you have two segments that are tangent, so in this particular case, their tangent point is R and T, and they intersect at a common external point, then you know that the segments RS and ST are congruent to each other. So that's if they are tangent points. So let's look at some examples here. This first one, it's asking us if ST is tangent to that point. Well, if it is tangent, then we know that the angle T must be a right angle. Oops, that didn't go very well, sorry. Must be a right angle. So we have those points, and if it's a right angle, then we know that the Pythagorean theorem would hold true. So if we think about that, our Pythagorean theorem would state that 12 squared plus 35 squared has to equal 37 squared. So 12 squared is 144 plus 35 squared, the calculator here, is 1225, and 37 squared is 1369. So the question is that a true statement? Well, is 1225 plus 144 the same? And when we add those two together, we get 1369. So we end up with 1369 is equal to 1369. So because that's true, then since Pythagorean theorem it's equivalent, then we know that that's a 90-degree angle. So yes, this is tangent. ST is the tangent to circle P. Now the other problem here, we have point B is the point of tangency. So I am telling you it is the point of tangency, which means that this is a right triangle. So if we think about this right triangle here, if that's my right triangle, there's B, here's C, and here's A. So A to B is 80. Here's our radius R. And then A to C is the 50 plus R. So here's our triangle. I'm going to go into a different app to be able to solve this. So we have a right triangle. We can use Pythagorean theorem. So if we redraw that here, this was R, this was 50 plus R, and this was 80. So we have R squared R squared plus 80 squared equals 50 plus R squared. So R squared equals, or not equal, why do I keep doing that? Sorry. R squared plus 80 squared is 6,400 equals, now here this really means 50 plus R times 50 plus R. So if we FOIL that, 50 times 50, I'm going to come over here, R squared. Why do I keep doing equals? Sorry, people. So 50 times 50 is 2,500 plus 50 times r is 50r. R times 50 is another 50r. And then r times r would be plus r squared. So when we solve this, we have r squared plus 6,400 equals 2,500 plus 100r plus r squared. If we combine like terms, I'm going to subtract r squared to both sides, and what's nice is the r squared cancels on both sides. So I have 6,400 equals 2,500 plus 100r. So then minus 2,500 gives me 3,900 equals 100r. Divide by 100. So my radius is 39 for that problem. Whoops, that's not what I wanted, sorry. So it asked us to find the radius, and we found that our radius was 39, and then it's saying feet, so then we would say 39 feet for that example.